Okay, hi and welcome to Notes 3.6, where we're going to talk about solving algebraically absolute value inequalities and equations. We're going to do both. All right, so we're going to skip over that part there, which is an investigation. We'll do that in class, but let's pose some questions here. So let's talk about what could be a solution for an absolute value equation. Okay, so here we've got one. It says 1, consider the following, right? So the absolute value of x equals 4. What values could I plug into that absolute value sign there for x that would be true? That would make that a true statement. What values could x be? Well, of course, the first one you're going to say is 4. You're like, well, Mr. Hallam, if I plug in 4 there, that's got to work, right? So the absolute value of 4 equals 4, or take the absolute value of positive 4, stays positive 4, does equal 4. Check. That's good. That's great. But if you were thinking kind of closely there, there's another possible solution, and I'm going to use the word and here because that's going to be big for us today, and there's another possible solution. What about the absolute value of negative 4? And the absolute value of negative 4 equals 4, and you're like, well, that's not true. But when you take the absolute value of any negative number, it becomes positive because all we care about is the distance, not the direction, and that's also true. So there's two possible solutions. There's always going to be, for whatever we plug in there, a negative or a positive version we should start with and a negative version. There's going to be two things that could make this true, a positive and a negative of whatever's in the absolute value. Okay, so that's the first thing I want to kind of get across because that's a huge point of what we're going to do today. Next, let's look at the second one here. It's very similar to the one on the top. This is the absolute value of x equals negative 4. So what can I plug in here? And I'll change my color and draw an arrow down here so we don't get lost. What can I plug in for x here? Well, let's try that again. Can I plug in 4, the absolute value of 4, and make it equal to negative 4? Well, no, everything in an absolute value, no matter what I do, is always going to come out to be positive. It'll always be positive. It doesn't matter what happens. Look, this one came out to be positive when we started with a negative. So there's just no way that I can make any of these negative. So if you ever see that your absolute value, when you've isolated it, and it's all by itself and there's nothing else by it, and that's the key here, that there's nothing else there, nothing that can be moved away or changed the way that it stands, and it's equal to a negative value, at that point you would say that there's no solution. Okay, there's no way to solve that one. There's no solution. It doesn't intersect the x-axis because we know that that's what solutions are. It's the intersection of the function and the x-axis. So how do we do this one on the bottom then? You're like, well, Mr. Hallam, I get this. I plug in 4 or negative 4, and they're both equal to 4. But what do I plug in for x here? I don't know. I got a whole bunch of numbers that I can plug in there. Well, this is where we come into our solving techniques, right? We're still going to use our old faithful, which is the reverse order of operations by inverse operations. But the only new piece that you have to do here is you have to make sure that your absolute value is isolated. All right, so that's the new piece here. So if we look at this absolute value, here's the absolute value. And when I say the absolute value has to be isolated, it means that there's nothing in front that's multiplied to it, and there's nothing behind it that's added or subtracted to it. So that's kind of what you're looking for, that there's nothing multiplied, added, subtracted, squared, cubed, anything to the absolute value. If it's all by itself, if it's isolated, then you go ahead and do what we did up here. You write one version of what's inside positive and one version of what's inside negative. So let's do that. Let me grab another color here because I'm starting to get colors all over the place. So I'm going to take this inside. So I'm going to write it once negative first because I like negatives on the left. Call me old-fashioned. So I'm going to say negative, and here's what's in the inside, x plus 3. So whatever was in the inside, I dropped off. I made negative, sorry. I dropped off the absolute value because we're done with it. What we're doing is we're separating this absolute value into the two parts that it could be, a positive version and a negative version. I'm going to solve both of those. So let's finish this up. There's my negative version, right? There's my negative possible insides, and here's my positive possible insides. Now I get x plus 3 equals 7. You're like, wait a minute, Mr. How come there's no parentheses there? And I would tell you that if I put a positive here, it'd be positive 1, and then if I multiply anything by positive 1, it's just itself. So I don't need the parentheses if I'm just multiplying by a positive 1. In this case, I'm multiplying by a negative 1. It changes everything inside. And you're like, all right, let's distribute, Mr. Hallam. Oh, don't forget the word and here, right? These are both this and this are possible solutions. All right, so let's go back here. And you're about to distribute, then you realize that you're solving and that I don't need to distribute this negative. I actually want it on the other side because I want to get to this x. So I'm going to divide by a negative. Right? So I divide by negative on both sides, or multiply. It doesn't make a difference. It's the same. It's a little secret. So I get x plus 3 equals negative 7. And then I'm going to go ahead and subtract 3 from both sides. I'm really using up all my space here. X is going to be equal to negative, it looks like 10. Okay, that's one of my possible solutions. And then this side, I'm going to go ahead and subtract 3 from both sides. I'm going to scoot over here. And I find out that x is equal to 4. So my two possible solutions are going to be negative 10 and positive 4. That's what this is going to look like. Now, we'll talk about what that looks like visually when we get back to class, but those are my two possible solutions. Where this absolute value, where this v-shaped function crosses the x-axis is going to be at positive 4 and negative 10. There you go. I just cheated. That's what it does look like. So let's talk about a rule. So first part that we have to do is isolate the absolute value. Use your standard rules, reverse order of operations, inverse operations that we need to use there. Okay. Then when you're done, you're going to write a negative and a positive version of whatever's inside the absolute value. Then you solve both of them. And then when you're done, you have your two solutions. If you happen to, when you isolate the absolute value, find out that you're equal to a negative number, that means no solution. Okay, so that's really the only new kind of thing that you got to pay attention to. I guess there's a couple new things there, not gonna lie. All right, so I'm gonna slide this down here. Here's a couple examples for us. Let's do some of these really quickly. I'm gonna look at this one again. Here's the absolute value of x equals 3. I'm gonna take this because this is isolated. I should probably start there. Erase, let's start over. Okay, here's number 1. Look at it. There's nothing multiplied to the front. There's nothing added or subtracted to the back. There's nothing to the absolute value. It's all by itself. So it is isolated. So now I'm going to write the insides of the absolute value. Once as a negative, once as a positive. So here's my negative. Negative x, right? I don't need a parentheses. There's nothing to distribute to. So negative x equals 3 and positive x equals 3. Don't forget the word and. These are both solutions. Okay, so this isn't solved for yet because I've got a negative there, so I'm going to divide or multiply by negative 1 on both sides. There's my negative 1, there's my negative 1, so I find out that x is equal to negative 3 and x is equal to positive 3. There's my two solutions. Okay, let's do another one. Again, check your absolute value. This is isolated. There's nothing multiplied or added or subtracted to it. So I'm going to go ahead and write a negative version and a positive version of it. So here's my negative version of my inside. Negative x minus 3 equals 6 and x minus 3. There's my positive version equals 6. So I'm going to solve both of these. Move that negative to the other side. So x minus 3 equals negative 6. And then I'm going to go ahead and add 3 to the other side. So x equals negative 3. Right, and my other possible solution is positive 3 to the other side here, so x equals 9. So there's my two possible solutions. Okay, so that was if something was on the inside of the absolute value. Well, now there's something on the outside of the absolute value. Again, the absolute value this time is not isolated, so I have to, before I write my positive and negative, move this 3 to the other side. Inverse operation of positive 3. I find out that the absolute value of x is equal to 8. And if you're paying attention over here, when you have just an x inside your absolute value, you find out that whatever that value is equal to, you get the negative and positive. If you want to use that little trick, or I don't want to say shortcut, or pattern is a better word there, you can. So you're going to find out that x is equal to negative 8 and positive 8. There's a little pattern shortcut for you. All right, let's look at 4. It's getting a little more complicated as we go. I'm going to switch my colors so we don't get confused. Looking at 4, I'll look at my absolute value here. Now, not only do we have something on the outside, we have something on the inside. So it's kind of a mix. So the first thing we have to do is isolate the absolute value, right? Step 1. So let's get rid of that 3. I'm going to divide by 3 on both sides. So now I'm going to go ahead and clean that up. Those reduce to 1. So I have the absolute value of x plus 1 equals 3. Now I've got my absolute value isolated, so I'm going to write a positive version of it and a negative version of what's on the inside. So here's my negative. x plus 1, there's a negative insides, equals 3, and my other possible solution is x plus 1 equals 3. Let's solve the one on the right because it's pretty easy. I'm going to subtract 1 to both sides. So I'm going to find out that x equals 2. That's one possible solution. I'm going to go ahead and divide this negative off to the other side. And so I'm going to find out that x plus 1 equals 2. And then I'm going to subtract 1 from the other side. So I'm going to find out that x equals 1. So my two possible solutions is x equals 1 and x equals 2. Let's do one last example. I'll change my color yet again, just so we have another one. Looking at this, we've got something on the inside. Great. We'll have to deal with that in a minute. But first, we have to isolate this absolute value. And I notice I got a negative 5 out here, so I have to move that away first. So the inverse operation is to divide by negative 5. So I get the absolute value of g plus 1 because these 5's turn into 1 there. Equals 2 negatives make a positive, so this is going to be 35 divided by 5, which is 7. Now I'm going to go ahead and separate this into my negative version and my positive version. See how this is going? You're starting to see this pattern? Excellent. So I'm going to get negative the term inside the absolute value, which is g plus 1 equals 7, and g plus 1 equals 7. That's my positive. Divide that negative to the other side, so I find g plus 1 equals negative 7. And then I'm going to finish this up, subtract 1 to the other side, so g equals negative 8. And subtract that 1 to the other side, g equals 6. So there it is. G is equal to negative 8 and g is equal to 6. These would be the x-coordinates of where this absolute value crosses the x-axis. So I don't know where the x-axis is, wherever it is. This spot here, that's the x-coordinate of 6, and this would be the x-coordinate of negative 8. Just the x-coordinate, right? So there you go. That's how you solve the first part of this, and that's what we're going to work with. Next, we're going to do is inequalities. So I'm going to pause the video, and I'll see you in a minute.